Okay, hey guys, Mr. Bedell and I were ready to start Chapter 5 here with you. And Chapter 5 is titled Relationships Within Triangles. So we're going to be talking about how sides and angles and so on, specifically inside triangles, relate to each other. Our first section of the chapter is titled Midsegment Theorem. So within that, of course, we need to define what a midsegment is. And so that's our first piece of notes here. The midsegment, which a triangle is going to have three, just like it has three angles and three sides, it's going to have three midsegments. The way you create a midsegment in a triangle is by connecting the midpoints of two sides of a triangle. So you can see in this diagram right here that A is the midpoint of that far left-hand side. M is the midpoint of the right side, and so by connecting those, and this one happens to be a length of 8, that's one of the midsegments. Okay, and so as we connect the separate midpoints of each side, we see the three red lines in there, line segments, that end up being the midpoints, the midsegments, sorry, of the triangle here. Okay, so once we have those midsegments defined, then they end up actually creating a special relationship within a triangle, hence part of the chapter name. What ends up happening is the midsegment theorem. And so here's the midsegment theorem. It said midsegments are parallel and half of the third side. So let's kind of dissect that a little bit. First of all, if we have a midsegment like AM, it's going to end up being parallel to the side that it is not connecting midpoints between. So in other words, the bottom of this triangle. So AM is going to be parallel to OD in this particular diagram. Okay, always. That always happens. No matter what kind of triangle it looks like, that ends up always happening. Okay. The other thing that happens is that the length of AM, in this case the 8, is half of that third side, so OD. So if AM is 8, what does that end up making OD? You would just double it, and so the length X down there would end up being 16. So the midsegment theorem tells us two things. The fact that the midsegment is parallel to the third side, and it also measures half of the other side. And typically we may go the other way with that. We'll take the third side being double the midsegment. Might end up being easier that way.
All right, so let's go ahead and do some application of the midsegment theorem. So if you look up in the corner there, it says that AC equals 20. So you got to find side AC up at the top there of the triangle. And so if we want to find DE, remember guys, the midsegment theorem says that it's parallel and half. And if you're running into a hard time trying to decide which pieces are the midsegment to a side you're talking about, just remember, it's got to be parallel to it. That's the key. That's what makes it easy. Find the sides that are parallel. And so if AC is the piece we're looking at, then DE is the piece that is parallel to that. And so all you have to do is cut AC in half. So if AC is 20, then DE has to be 10. Okay? So let's look at another piece now. If they tell us that DE is 4, okay, now who's running parallel to DE? Well, that would be side AC at the top of the triangle. So if DE is 4, now remember, it's half. So we're going from the smaller piece now, guys, to the larger piece. And so instead of dividing by 2, now we have to multiply by 2. So remember, when you go from the smaller to the bigger, you're going to multiply by 2. When you're going from the larger to the smaller, you're going to divide by 2. So in this case, we multiply by 2. So AC will be 8. So here we have NO equals 3x plus 8, and we have WY equals 2x plus 24, and they want us to find NO. Okay, so we have to find the length of that midsegment there, NO. Now remember, guys, we're not trying to find, we need to find x, but x is not NO. Okay, x is only the variable, NO is the length of NO. So once you figure out what x is, don't forget to go back and plug it back into 3x plus 8, so that way you can get the actual length of NO. Okay, so remember that NO is the midsegment of WY, and if you follow the midsegment theorem, we know that NO is half the length of WY. So we need to make an equation out of this real quick. So if you think about it, if NO is half of WY, if we multiply NO by 2, it should equal YW, as you can see over there on the slide now. So now that we've established that if we multiply NO by 2 or we double NO, it'll give us WY. Now just go through and start to substitute in the algebraic sentences. So instead of 2 times NO, we're going to go 2 times 3x plus 8 and equals 2x plus 24, as you see right there on the PowerPoint. Now, From here, it just becomes, some basic algebra. First thing we need to do is to distribute. And so once you distribute that 2 across the 3x plus 8, you get 6x plus 16 equals 2x plus 24. Now all you got to do is some subtraction property. So that leaves you with 4x equals 8. Divide by 4 to both sides, and you get x equals 2. Now remember, that is not the final answer. You got to take that 2, plug it back into NO, or into 3x plus 8, so that way we can get the actual length of NO. And once we have that, 3 times 2 is 6, plus 8 gives us 14, which you see now on the PowerPoint. Remember, guys, the key to this is you got to remember that midsegment clearly states that that midsegment is parallel to the outside side of the triangle that it's running with, and it's half of the original length. Okay? And anything else, Mr. Scritchfield?
No, I think that's it.
All right.
Okay. We'll see you guys
tomorrow.
in class.